Hello, everyone. Thank you for joining us today for our session on cost optimization best practices for Google Cloud Storage. My name is Lauren, and I'm the content manager for the Google Cloud community. And joining us today is technical account manager Samara Casa, who will be leading the presentation and answering your questions. Questions are encouraged, so please feel free to add those into the YouTube chat box, and we'll be sure to get to it either in the chat or at the end of the presentation. We also had a few pre-submitted questions that we'll cover in advance of those live questions as well. For any questions that we don't get to, please utilize the Google Cloud community, and the link to that is in the YouTube description. So it's here where you can ask questions, engage in forums on different products and topic areas of Google Cloud with your peers and Google Cloud experts. So we'll be sure to monitor the forums and provide an answer for your questions. And with that, again, please don't hesitate to add your questions or comments into the chat, and I'll hand it over to you, Samara, to take us through the content today.
Thank you, Lauren. Hello, everyone. Hope everyone is having a great day so far. So something exciting. So, do you know that Google will turn 25 tomorrow? Those who would be sharing their birthday with Google and celebrating their birthday this month, I hope you all have a fantastic birthday. And speaking of birthdays, reminds me of a childhood conversation I had with my mom, right? And as a kid, I sometimes would get cash as a birthday presents for my parents and from my grandparents. And usually I would want to spend all that money. And my mom once said that do not spend more than I really need and save the rest of the money and put it somewhere for future. So I saved up some money and contributed towards my first bicycle. And I really think the same concept also applies to your cloud spending as well, because what we see is no organization wants to spend more than they really need to, because the unnecessary spending can be used towards a POC that you are planning to do or an investment to some of the new workloads that you are planning to do, etc. And in the next few minutes, we will talk all about how to optimize your spend in Google Cloud. I'm Samara, Technical Account Manager based out of Toronto, Canada. I'm so honored and excited to walk you through the cost optimization best practices for one of my favorite services, Google Cloud Storage. So without further ado, let's jump into today's session. In the next few minutes, we will look into the features and differentiators of cloud storage on a very high level. And then we will discuss the key factors that influences the cloud storage architecture as well as its costs, and what are some of the best practices that you can choose across these factors to optimize your spend. And we will conclude this session with the Q&A and any resources that you can leverage to learn more about cost optimization. So what's cloud storage, right? So for those who are not familiar with cloud storage, it's an object-based storage service that's great for storing unstructured data. And what I really love about GCS is that you can store virtually any amount of data and retrieve it as often as you like. Some of the cool features of GCS is that it's very simple to use with consistent APIs across the storage classes that it offers. And it also has a global single endpoint for all the classes that GCS has. Second, it's highly reliable with the highest SLAs, and you get zero RTO with automated failover and failback. And third, it's secure by design to protect your data, and it offers many advanced controls to keep your data secure against any leaks or any compromises. And last but not least, it's highly scalable because it uses the same infrastructure as Google. So it's great for extreme scalability use cases. Within cloud storage, we have customers ingesting and egressing like petabytes of data daily and sharing their data with the users across the globe. While storing the data in GCS is easy peasy, and it's also cheap because it's penny or less per gigabyte, your cost could add up if you're not really careful. And if you have many applications running and if your needs are changing over time, it can be difficult to optimize your GCS costs as you ramp up. But don't worry, I'm here to help you. As a technical account manager, part of my responsibility is to offer direction to our customers on making decisions on how they can reduce their costs and help them get most out of their cloud investments. So, in the next few minutes, I will walk you through some of the approaches that we have seen our customers taking to save their money and to optimize their costs within GCS. So in case of GCS, there are a number of ways that you can optimize your costs. And we will focus on the three key dimensions that will influence your costs and the approaches that you take to optimize your spend. First one, data location or data residency. So this is about picking the appropriate location type because the location type that you pick will influence your costs. And picking a right location is also very important as it can help with minimizing your costs without sacrificing your application performance. The next factor is data access patterns. It's very important to understand how often your data will be accessed, as it will help you pick an appropriate storage class. And the opportunity here to optimize costs here is that GCS offers 4 different storage classes, which we will look into in a minute, each with its own performance and pricing characteristics. So if you have a good idea on what your data access patterns are, you would be able to narrow down a class that offers a best price to performance ratio. And the next one, data retention and management. So understanding how long you would need to store your data and managing your data lifecycle that aligns with your requirements can significantly reduce your costs. Within GCS, we have capabilities such as Autoclass, object lifecycle management, storage insights reports that you can leverage to efficiently manage your existing data within your buckets. So in the next few minutes, we will look into all the best practices that are listed on this sketch. I had a privilege to co-author this fun little sketch along with my wonderful colleague, Patik Sharma. This sketch shows the list of best practices that we will be discussing today and see how each of these best practices aligns to the factors that I just discussed. Right, so let's look into the first factor, data location. So let's start with some of the challenges and warning signs that we see within our customers. The main challenge, as the name suggests, is understanding which location to choose that serves your user in a best way, and picking a location type that offers you best cost to performance ratio. These are the two main challenges that we prevalently see within our customers. And some of the warning signs that would hint you that there is an opportunity to optimize more in this factor is that if you see a lot of egress charges, especially network charges to GCS, then it's a warning sign that you can optimize further. Or if you see large amounts of data in multi-regional bucket types, this might be because the default selection when you create a bucket is multi-region. And when you do not actively pick and choose the location type, it defaults to multi-regional, which is comparatively higher price compared to the regional location type. So if you see majority of your bucket types multi-regional, look and see if it's intentional or unintentional, and if you really need multi-regional buckets. And if you are writing short-lived data into, say, multi-regional or dual regional, when you really don't need data to be replicated across region, it might be an optimization opportunity because multi-regional and regional cost you more because it incurs some replication charges. So look and see if you really need multi-regional and dual regional for your use cases. And last but not least, if you have content serving use cases, the big warning is if you're not using CDN and you're directly serving traffic through internet, you will be seeing more high internet egress charges. So an optimization opportunity is consider leveraging Cloud CDN so that you can significantly reduce the bandwidth charges. So now that we saw the challenges and warnings, let's see how we can go about addressing those challenges and warning signs, right? So basically, there are two key ways. Number one, picking the right location type, and two, using Cloud CDN for content serving use cases. So let's look into the first box, right, which is choosing the location type. I will talk about how you would go about choosing a location type that best suits your application in a few seconds. But before that, let's see what are the different location types that GCS offers. So there are essentially three location types that you can choose from. Number one, regional. This is optimized for cost. The data is geo-redundantly stored across across zones within a single region, and it's great for co-locating your storage with your compute resources. It is also optimized for cost since it is the lowest storage price compared to the other location types. And it's good for scenarios where you do not want your data to be replicated across the regions. So if you don't want the data to be replicated across the regions, regional location type would be your best choice. The second location type is multi-regional. So here, data is made geo-redundant across these regions within a single continent. The key thing is the locations in which the data will be stored is not something that you can choose. Google chooses it on your behalf. With this location type, you will be guarded against any kind of regional failure because the data is replicated across regions, right? And it is also great use location type if you have geo-distributed users to whom you are serving content, and high availability is your prime requirement. Moving on to the third location type, which is dual. Here, the data is located in two regions that you can choose from. So it offers high flexibility since you have a choice to decide which region that your data would like to reside in. Even here, just like regional, you will have control to co-locate your storage with your compute resources. So for example, say you have US dual regional feature. You selected US Central and US East. You could have your you could have your compute resources sitting either in these two regions and be reading from one of the regional buckets for free. So egress within the same region would be free within the dual region location type. And in terms of use cases, it's great for high performance workloads where you want good performance, but with egress charges in control and in check. So now that you saw the three different types of location types that GCS offers, let's see how to choose a location type for your use case, right? So now coming on to choosing a location type, we came up with this good framework that helps you choose the right location type for your workloads. So starting from the top, if you have all the data in day, make sure you assess if content serving is your main use case. If it is, then continue using multi-regional location type. But if it's not, and if analytics is your main use case, understand if you need geo-redundancy. If you do, then migrate to dual region. If you do not need geo-redundancy, then migrate to regional buckets. If analytics is also not your use case and backup and archive is your main use case, figure out if you need geo-redundancy for your backup and archive. If you need geo-redundancy, then go to dual region. But remember, dual region also costs more compared to the other location types. And if you do not need geo-redundancy at the regional level, then you choose the regional location type for your data. And one last thing to remember, uh, always remember to co-locate your storage with your compute resources, because if your compute resources and storage is in the same region, you can significantly optimize costs in terms of the egress charges. So that's the recommendation flowchart. So keep this in mind when you are choosing the location types for your data. Keep this handy, and this will definitely help you pick a right location type for your data. So we saw the first factor, which is choosing a location type, right? And moving on to the next one, which is CDN. Say you have content serving use cases, and where you are serving your users across the globe, right? If you're not using CDN today, be sure to look into CDN, and we would highly recommend to consider using a CDN, right? Cloud Content Delivery Network, because Cloud CDN can reduce bandwidth costs because it caches content closer to the users, and so it will remove the burden from your origin servers. This will reduce the amount of bandwidth that you would use to deliver your content, and thereby significantly reducing the bandwidth costs that you would incur without a Cloud CDN. It also helps to reduce egress costs, because if you are using a content delivery network to serve your content to your users outside your primary region, Cloud CDN can reduce egress costs because it serves the content from the edge locations or edge servers that's located within the user's region. And along with the cost optimization benefits with CDN, you can also provide a good user experience to your end users, because CDNs will bring content closer to all the visitors, no matter where they are. So the content is delivered fast, and it significantly improves the access speed and the overall user experience. So that's about the first factor, which is choosing the right location type and using CDN for your content serving use cases. So moving on to the next factor, which is data access patterns. Data access patterns is all about understanding how frequently your data is accessed and figuring out a correct location, correct storage class that aligns with your data access patterns. Some of the common challenges that we see within our customers are misalignment between data access patterns and the storage classes that they choose. For example, customers may choose, if you do not know the data access patterns well enough, there might be a potential issue that you would choose archive, say, for your hot data, or you would choose standard for your cold data. And lack of that knowledge in terms of which storage class to use for which data type will cost you more. And one of the other challenges that we also see is not moving the data across the different storage classes. So as the data becomes older, if the data access patterns changes, some of the customers won't be using either object lifecycle management policies or Autoclass features to transition the data between different storage classes. So that's also some of the challenges that we see within our customers. And some of the warning signs that will tell you that there is an opportunity to optimize more is look and see within your landscape if you're using one storage type. We have four storage classes within GCS, each catering to a different access patterns. If you are seeing just one storage class, maybe for example, standard for all kind of data, look and see if it is really aligned with the data pattern, the data access pattern that your data has. And if you do not have any object lifecycle management policies, that's also a warning sign, because with object lifecycle management policies, you can transition your data between different storage classes. And also you can delete the data once you think that you don't need it anymore, and significantly saving in terms of costs. And the other warning sign is that if you see more data retrieval costs and operations costs for cold storage, that means the data is probably hot, and cold storage classes might not be the right storage type for such data. So consider moving them to a hot storage because the data is hot, and so that it's optimized for future accesses. So now that we saw some of the common challenges and warnings, let's see how to address those challenges and how to go about addressing those warnings, right? The opportunity here is that, as I said, GCS offers four types of storage classes: standard, nearline, coldline, and archive. By choosing a storage class that best aligns with your data access patterns, will offer you best price and performance ratio. So once we cover the types of storage classes, then we will look into Autoclass and object lifecycle management policies that will help you to automate the data transition between the storage classes, and also to efficiently manage the data lifecycle. So let's look into the first factor, right, which is the different storage classes that GCS offers. The color coding that you see here is intentional, which represents the data access frequency. Standard, it's great for hot data, hence the red color. When I say hot data, it means it's great for data that's accessed very frequently. And it is also the best class if you would like to store the data for short periods of time, short-lived data, aka. So it's great for, in terms of use cases, it's great for serving your website content or for streaming your videos. The next storage class is nearline, and this is best for storing infrequently accessed data. For example, if you plan to read data or modify your data on average, maybe once per month or less, then nearline is the appropriate storage class for you. And the appropriate use cases for nearline is that if you are storing data for backup and archival, nearline would be the best option that you can choose from. The third storage type is coldline. This is a very low cost storage class, and it is also suitable for infrequently accessed data. This is greatly ideal for data that you plan to read or access or modify at most once a quarter. If you have such use cases, coldline would be the best storage class for you. And last but not least, the archive storage class. So this is the lowest storage class, and archive storage is the best choice for data that you plan to access less than once a year. And one key differentiator of archive storage class is, unlike the coldest storage services offered by the other providers, your data is available within milliseconds instead of hours or days. So, and one other important thing to note is, if you are keeping the data entirely for backup and archiving purposes, archival storage is the most cost effective, as it offers the lowest storage costs compared to the other storage classes that are available within GCS. So now that we saw the storage classes, and I said, as I was saying, aligning your storage classes with your data access patterns is the best approach in terms of optimizing your costs. But choosing a right storage class when you know data access patterns is easy peasy, right? And anybody can do that. But I know it's not always that case, and it's not always that easy, right? And what if you don't know how frequently your data will be accessed, right? Or what if your data access patterns are frequently changing? And in that case, how can you choose an appropriate storage class when the access patterns are not constant and they're dynamically changing all the time? So this is where you can leverage the Autoclass capability. So with Autoclass, as the name suggests, it helps with automatic classification of data or automatic transition of data across the storage classes. Here, you do not need to define rules from your end because Autoclass will automatically transitions objects based on the object's last access time. Easy peasy, right? So, for example, if there is an object that's not accessed for 30 days and the object is in standard, Autoclass will see like, oh, this object is not accessed in the last 30 days. Let me move it from standard to nearline. Say if the object is in standard and it's not accessed for 90 days, Autoclass will move it to the core line. The other important thing to note here is that Autoclass can also move the data from colder storage classes to the hot storage classes. For example, if you access the core line object, Autoclass will notice it and it brings the data back to the standard class that's optimized for your future accesses. Note that when you're using Autoclass, there is a slight management fee. I think it's like 0.002 for every 1,000 objects per month. So keep that in mind when you're enabling Autoclass for your buckets. And from cost optimization perspective, Autoclass does get rid of fees such as deletion or retrieval fees that are associated with coded storage classes. What I meant by that is essentially there is no deletion or retrieval fee. So say you have a bucket with Autoclass enabled and Autoclass moves the object to a core line storage and you want to delete that data, you won't be incurring any deletion fee. So that's the main advantage of Autoclass from the cost optimization perspective. So we covered the second factor, which is data access patterns, and we looked into the different storage classes and how to align them with your data access patterns, and how to use Autoclass in terms of efficiently managing your object lifecycles. So let's move on to the next factor, which is data retention and data management. So data retention and data management is also key in terms of optimizing your costs effectively and efficiently. So some of the common challenges that we see within these factors is that customers sometimes lack awareness on in terms of what their data retention requirements would look like how long to retain a specific amount of data. Can they delete the data after X number of days or X number of months, or how long they should keep them, right? And some of the warning signs within this dimension that we see is if you do not have, say, defined policies with regards to data retention, that might be a warning sign that's telling you that there is an opportunity to optimize more within this domain to see cost reductions. And secondly, if you see increase in regional storage data instead of drops as you go on getting more and more data into cloud storage, that could also be one of the warning signs saying that potentially there is an opportunity to look into your data retention requirements and see if any old data can be deleted or archived or moved to a colder storage classes so that you can see some cost savings within GCS. So we have gone through some of the challenges and warning signs within data retention and management, but how to address them, right? So the first thing, the first opportunity here is using Autoclass or lifecycle management policies. We already covered Autoclass in the previous section, and in this section, we will focus on OLM, Object Lifecycle Management Policies. In addition to OLM, you also have capabilities such as versioning and storage insights reports, that you can use to cost efficiently manage your existing data, which in turn could help you bring some cost savings. So let's look into OLM, Object Lifecycle Management, first. So a few seconds ago, we saw Autoclass, which automatically transitions data across the storage classes based on objects' last access time. Now, Object Lifecycle Management is a DIY version of Autoclass. So it basically, with Object Lifecycle Management, it helps you set tiering policies so that you can move your data across the storage classes or delete the data that you do not need anymore. So with Object Lifecycle Management policies, you can configure rules as per your requirements. For example, with OLM, you could configure set storage class rule that says move so-and-so objects to nearline after 60 days. Now, you could choose to move your objects based on your custom timestamp, based on the object's age, object's creation time, or based on object's prefixes or suffixes. So you would have more control in terms of how you can configure rules as per your requirements. So any scenarios where the access patterns are predictable and you have identified the objects that you could move to a certain storage class or delete them, Object Lifecycle Management would be your recommended option because it gives you full control and you have full access in terms of how you would like to configure the data transition rules as per your requirements. One important note that I would like to call out is that it's only with OLM, it's only possible to move the data from hotter storage classes to colder storage classes. So for example, you can move the data from standard to nearline, nearline to core line to archive, or from standard to archive, basically from hotter to colder. But you cannot transition the data from colder to hotter. For example, you can't move the data from archive storage class to core line, for example, or from core line to nearline. So the other way around is not possible. And the other important thing is there is no cost for the rules that you will set. But if an object is moved from one class to another class as a result of OLM, you will incur class A operation charges for those transactions. So, okay, let's see the cost considerations with Object Lifecycle Management, right? So I put an example in the next slide that will help you, how to understand how OLM charges when there is object transition between one class to another class. So on this slide, as I said previously, there is an early deletion charges and retrieval charges with OLM. So on this slide, I have put an example. Say you moved an object from standard to nearline. Yes, it will save you on storage costs, but say you deleted the object at 20-day mark. Now you would pay for the 10-day early deletion charges since you deleted the object before the set time that it has to be present in the nearline storage classes. So OLM will help you save on storage costs, but if you do not use it properly, you can see some spike in operational charges. So, so keep in mind saving on storage costs versus spike in operational charges is a key to consider when you are setting OLM and using the rules appropriately. And to set your OLM rules appropriately, it's key to understand how your data access patterns would look like. So we covered two concepts, right? One is Autoclass, which is an automated way to transition data between storage classes. Next one, we just covered OLM, Object Lifecycle Management policies. Essentially, both of them kind of does the same thing, right? transitioning objects between the storage classes. So you have two options, which one to choose, OLM or Autoclass, right? So in the next slide, we put in a deciding factor to help you understand which option to pick. So the key deciding factor when you're choosing OLM or Autoclass is the data access patterns. So for example, if you have well-defined data access patterns that mostly stay the same, then we recommend that OLM would be your recommended option to go with. Because first of all, you will have more control in your hands on how you want to configure rules and how you want to optimize your costs. And two, you can set time periods based on your requirements, and you can set storage classes based on your requirements. On the other hand, if you do not clearly know the data access patterns, or if your data access patterns are dynamic and they change very frequently, then we would recommend to choose Autoclass. Autoclass would be your recommended option because Autoclass is like a set and forget kind of a bucket setting. It will monitor the object's last access time within the bucket, and it will move to the appropriate storage class that's optimized for future accesses. So in summary, if you clearly know your data access patterns, OLM would be a good option for you. If you're unclear about your data access patterns, or if the data access patterns are very dynamic and frequently change, you can choose Autoclass to transition your objects and to optimize your costs. So the next capability within data access, data retention and management is object versioning. So when you're using object versioning, enable it judicially. So what I meant by that is use object versioning for the objects that truly need it, because every version of an object will incur a storage cost. So if you keep enabling versioning for data that really don't need it, you could ramp up your costs, unnecessary costs, basically. And when you enable object versioning, consider also defining lifecycle policies to remove the stale versions of the objects as newer versions of the objects become more non-current. Because as I said, each version of an object, irrespective of whether it's live or not, will be charged at the same rate as the live version of that object. So make sure that you define lifecycle policies so that you could delete the older versions of objects when you do not need them, and thus saving costs by reducing the amount of data that you store. And last but not least, say you enabled object versioning, and down the lane you figured out, okay, for this data, we really don't need any object versioning policies. So identify such data and turn off that feature so that you won't, GCS won't keep creating the new versions of objects, so that you can also significantly reduce the storage costs that you will see. So that's about the object versioning and some of the best practices that you can follow in terms of optimizing your costs. So the last best practice within data retention and management is storage insights. This is a new feature that we introduced very recently. I think it's in month of June or July. So the idea here, how the storage insights inventory report helps you is that when your data volume increases, it gets harder and harder to efficiently discover and manage your objects, right? And at the same time, when your data volume increases, it would also be very challenging to discover the cost optimization opportunities as well. So this is where the storage insights inventory report would help. What it basically does is the report includes the metadata about your objects, such as object storage class, size, e tag, content type, and many other details. So you can import these reports into, say, your analytics products such as BigQuery or to SCSV, and do further analysis and audit and validate your objects, to analyze your storage expenses, to identify the objects that are no longer needed, so that you can remove them, which in turn lowers your cloud storage costs. So if you are not aware of the Insights inventory report, I would highly recommend you to go check it out, because you can leverage this feature to routinely monitor the data that's stored within your GCS buckets at scale. And as I said, identify the cost optimization opportunities, such as, you could understand whether object A is being accessed recently, or was it accessed maybe last year, can be like deleted, so on and so forth. So you could analyze your storage expenses and identify what are some of the opportunities, some of the avenues that you can take to implement the cost of approaches. So that concludes the best practices across the three key dimensions or factors that influences your cloud storage. So we covered best practices within data location dimension. Then we looked into data access patterns, which is aligning these storage classes with your data access patterns. And lastly, we looked into some of the best practices within data retention and management, which is nothing but using OLM, Autoclass, storage insights reports, and versioning. And one last important thing is, yes, sure, these are the key dimensions that will influence your storage costs, but it's also important to understand where your cost is coming from, right? Where your usage is coming from. Because once you understand where your usage is coming from, it will help you identify what is generating your costs, and helps you to be aware when your cost goes sideways, so that you can take preventative measures in future, or stop the expenses going further beyond out of control. So how to gain visibility into your usage and your costs, right? So there are three key ways here. So number one is leveraging cloud monitoring dashboards. Now, cloud storage is tightly integrated with cloud monitoring. So be sure to leverage the monitoring dashboards to understand and to be aware of spikes in usage, storage operation trends, data retrieval, and data deletion trends. Because if you understand the trends, you could analyze them and identify the opportunities, or identify the gaps where you can fill in to optimize your costs further. Second one, it's the most important one, is labeling, right? Be sure to label your GCS resources. Now, we understand labeling is an optional capability, but never neglect labeling your GCS resources. For that matter, any Google Cloud resources, right? So label them, because labels are very useful and comes very handy when you would like to do cost allocation. And it is also great for driving financial transparency. So on the image above, I have listed down the recommended labels for your GCS resources. Look through these and see if you have these labels set up for your GCS resources. Each of these labels will serve a specific purpose. So map back to your existing landscape to see if you have assigned these labels to your GCS resources. Last but not least, budgets and budget alerts, right? This is very important, because using budgets and budget alerts will help you be informed on your costs and can potentially avoid overspending. So budget alerts are great way to know when you're crossing certain threshold, say your budget, and you will get alerted when such things happen, and you can potentially go and analyze and see what has caused the cost go up above your threshold, and see what measures that you can take in future to keep the costs under your budget threshold that you set. So basically, these are the key three key things that you can use to gain visibility and understand your GCS usage and costs. So to wrap up, we have we have looked into these 6 key best practices that will help you optimize your costs. Number one, pick a location type to map to your workloads and use cases. Two, make sure that you align your storage classes based on your data access patterns. Number three, leverage Autoclass or object lifecycle management policies, storage insights reports to efficiently manage your the data lifecycle. Be sure to leverage cloud monitoring dashboards and billing management dashboards to monitor your usage and costs, to identify cost trends, cost anomalies. If your use case is content serving, make sure to look into CDN, and we would recommend considering CDN for your content serving use cases. And last but not least, make sure you tag or label your GCS buckets so that it will help you drive financial transparency and help you with cost allocation. So that's a wrap, and I would like to hand over to Lauren to cover the resources that are available to you and what's coming up next. Lauren, over to you.
Fantastic. Thank you so much, Samara, for this presentation and information. We do have an event feedback form, so I just dropped that into the chat. So if you have any suggestions for future topics or feedback on this event itself, we'd love to hear from you. It should just take 30 seconds to a minute to complete that, and we'd love to hear from you. Additionally, Samara, if you don't mind going to the next slide, we also have the link to the Google Cloud community, which is in the YouTube description. And this is where you can continue the conversation, stay up to date on future events, and ask any additional questions that you might have. And then lastly, we do have a few upcoming events. So tomorrow we have one around data monetization, AI readiness on October 4th, and then a data analytics with Gen AI Ask Me Anything event on the 11th. So that's just a teaser to some of our other upcoming events, but you can see them all at that third link there. All right. Well, thank you again. I know we have some of your questions, so we're going to dive right into those. Before we do, we are going to cover a couple pre-submitted questions. So let's start with that first one here, and then we'll be sure to get to those in the chat. So thank you for your patience. This first question here is, what is the cost of reading from multi-region US bucket via US GCE VM with an external IP? If I have a VM with an external IP and say region US East 1, that reads data from a multi-region US bucket, would that read operation be free or count towards download worldwide destinations?
Thank you, team, for that question. So the reads from multi-regional buckets from a VM in the same continent, for example, a VM in US East 1, reading from a multi-regional bucket within US continent will be charged against the networking traffic egress cost for GCP multi-region within North American continent. So yes, there is a SKU. I do not remember the specific SKU that you will be charged to, but we'll make sure to share it within the community. But yes, there is a cost for reading from multi-region US bucket via a GCE within US with an external IP.
Great, thank you. All right, our next question is, I have a file which I moved in the same Google Cloud Storage bucket using the gsutil command. How does the pricing work in this specific case because I need to move a lot of files? Will I be charged for moving the file in the same cloud storage bucket?
That's a good question. So moving a file is same as rewriting it. So it will definitely incur class A operation charges for the destination storage class. So if the original objects are in nearline, core line, or archive, it will also incur any applicable data retrieval or data early deletion charges. So it doesn't matter whether the destination is in the same bucket or a different bucket. The same charges would apply in this use case.
Makes sense.
So,
All right, we'll go to one more and then hop over to the live chat for now. So in the case of having many updates on I/O files on-prem, is it still good to use cloud storage when migrating to the cloud? How to implement an effective solution for this use case?
that's a tricky question. So I am assuming the question is about if GCS is an effective storage option for files which are updated periodically. Um, so if yes, yes, GCS would be an optimal solution that you can choose. And within GCS, for this specific use case, the appropriate storage class would be standard. Since you mentioned that you would be performing many updates on these files within on-prem, I would assume the same applies when you migrate these files to cloud. So basically, to me, the data looks like it's frequently accessed data, just nothing but hot data. So since you will be performing many frequent updates periodically and accessing the data periodically, standard would be your go-to class because it would give good price to performance ratio. Hope that helps.
Excellent, thank you. All right, so I believe you have covered some of this content in your presentation itself, but we'll resurface some of these questions if there's any additional elaboration or context that you can share. So that first question is around Autoclass, when we should not use it and what its latency might be.
So yeah, we already covered Autoclass a few minutes ago. So Autoclass, nothing but it helps you with automatic transitioning of objects within between the storage classes based on the last accessed time. So when you shouldn't use it, right? So we also covered differences between OLM and Autoclass. So Autoclass would be the recommended approach when you are a little bit unclear in terms of the data access patterns. In such scenarios, Autoclass would be a good option to choose because since it looks into the object's last access time, it will transition the objects within the storage classes that aligns with the data access behavior for that specific objects. So all in all, if you do not know the data access patterns are unclear, or if the data access patterns are changing very frequently, then Autoclass would be your go-to option.
Perfect, appreciate that.
And what is its latency? Sorry, Lauren, there was another follow-up question. What's its latency? So when you say latency, I'm assuming you're referring to like the time that it takes to move object from one class to another class. So I do not know the answer 100%. I will have to go back and look, but I would say it mainly depends on the object size. I would say in terms of how much time it would take and what's the latency between transitioning that object from one storage to another storage class. I will go back, validate my understanding, and post my response in the community chat that we have.
Fantastic. Thank you. Okay, we have two more. So if you do have any additional questions, please let us know. Can you talk about early retrieval and delete charges and how to interpret?
Okay, so for colder storage classes such as nearline, core line, or archive, when you delete the data within the set amount of time, you would incur early deletion charges. The same applies for early retrieval charges as well. And you can potentially cut down on this by using Autoclass. So when we were covering Autoclass, there was this one example that we shared, saying that with if you are using Autoclass and if you transition the objects between the storage classes, you won't be potentially incurring the data retrieval and deletion charges. So there is a nice example within the GCS pricing page as well. I will make sure to share that example so that you will have more idea in terms of how the data retrieval and deletion charges would work here.
Great.
I hope
Appreciate
that helped, Jay Kumar.
Great. Okay, we have time, I think, just for one more question here. So we'll take this one. Could you please elaborate more about retrieval time for data in archive class, how Google Cloud provides faster data retrieval? So I know we covered similar just now, but if you have any additional context to share here.
Yeah, so the insights that I shared for Jay Kumar's question also kind of addresses much these question. But what's really interesting to me is how Google Cloud provides faster data retrieval. That is something really cool, but I really don't know the answer on top of my mind. But what I will do is I will go back to the GCSPM and get insights on this. Even I wonder how we would provide faster data retrievals for archive class. That's something interesting. But let me find insights to it and get back to you. But thank you very much for that question.
Fantastic. Thank you all. With that, I think that concludes our session for today. So thank you so much again, Samara. This has been fantastic. Again, so many learnings and information that we can take away from this session. So thank you. Thank you, everyone, for joining us. Please do stay in touch. Join us for our next event and find out about those in the Google Cloud community. Again, that link is in the YouTube description. With that said, any final thoughts or recommendations before we close out today?
Yeah, sure. So first of all, thank you very much for the opportunity to present today. And I really had fun organizing the content and building this deck. And I learned a lot. And I hope you all also found this session helpful and insightful. Be sure to check out the links that we shared in the description to learn more about cost optimization best practices within GCS. And every week on Friday, our FinOps lead, Patik, he shares a fun sketch note that I shared a few minutes ago, outlining the best practices, not just for GCS, but across the Google Cloud services. So be on lookout for those fun sketches. And last but not least, Samara Casa is my username within LinkedIn. If you have any questions or if you would like to have a quick chat, please feel free to reach out and I would be happy to connect. Lauren?
Fantastic. Fantastic. Thank you, Samara. And thank you, everyone. We hope to see you next time.